I'd like to look at page 296, problem A1. They want us to prove, if A implies for all x bx, then you can conclude for all x, A implies bx. Okay, so let's start our proof. So the first thing we'll do is write our assumption, and our assumption is that the sentence letter A implies for all x bx. So that sentence letter A is like a TFL kind of propositional sentence. Has no variables. It's not a predicate because it has no. Well, it is a predicate actually. It's a what they call a nullary predicate. It's a predicate that has no variables. So those are called nullary predicates. Anyway, that's our starting point. Now we want to end up with a universally quantified statement for all x, A implies bx. Now that means essentially we want to sort of, effectively we're wanting to pull that for all out front. Okay. Now you can't treat this like algebra in that something can pull out front like factoring. Okay. I mean, it sort of looks like factoring, but to call it factoring is not really correct. So the strategy I'm going to take is I'm going to assume A, and then I'm going to arrive at B of some some B of some statement. I'll then end my subproof, and I'll have an implies that won't have the for every in it. And then we'll see what happens. So I'm going to start this with a subproof starting with A. And from there I'll get for all x bx. And that's, of course, just implies elimination on line 1 with antecedent 2. And now I have the freedom of eliminating that for all. Now I couldn't have eliminated it here. You can only eliminate a for all when it is the main logical operator. So since it's not until line 3, now we can say, well, B of whatever named constant we want. Let's maybe choose little a. You could choose anything in the first half of the alphabet. And that's for all elimination on line 3. So I can conclude from this subproof that A implies B of little a. That is implies introduction on the subproof from 2 to 4. Well, that's just great, because now I have a statement with a named constant in it, little a, and that named constant doesn't appear in any undischarged assumption. Okay, there's two assumptions in this entire proof. There's line 1 and line 2. Neither of them contain a, and even this one doesn't matter because it's discharged. So there's no a anywhere else, so we are welcome to universally quantify over little a. And so we arrive at this. And that's for all introduction on line 5. And that's what we wanted to show. We wanted to start with A implies this, and then end with for all x, A implies that. And, oh, I made a mistake, didn't I? Put an x right there. Then we've correctly done.